Hello students, today in your algebra class you're going to be working on special parallelograms. So just to start, let's try a couple of quick warm-up problems. So this would be a good time for you to pause your screen and try working out these problems right now. Hopefully you've paused your screen and you've worked on solving these. You should have gotten 3x plus 6 equals y plus 4, because in a parallelogram opposite sides are congruent. Then you should also have 2y plus 2 equals 3y minus 9. Then you should be able to solve for y at first by adding 9 to both sides. You would have gotten 2y plus 11 equals 3y. Then we're going to subtract 2y from both sides, giving you y equals 11. Then you can substitute that y into the second equation, giving you 3x plus 6 equals 11 plus 4. Then by combining 11 plus 4, which is 15, and subtracting 6 to both sides, you'd have gotten 3x equals 9, and x equals 3. Second problem, because we have a parallelogram, then we have parallel lines. Therefore, we have alternate interior angles with these two angles. Therefore, 4x minus 1 equals x plus 38. Subtract x to both sides. 3x minus 1 equals 38. 3x equals 39 because we added 1 to both sides. And x is equal to 13. So at the end of this lesson, you should be able to identify special parallelograms. So it's really important for you to write these 3 sets of notes, or these 5 theorems on your paper, and we're going to work on them together to re-explain them. Theorem 6.9 states that each diagonal of a rhombus bisects 2 angles of the rhombus. Theorem 6.10 states that diagonals of a rhombus are perpendicular. Theorem 6.12 says if one diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. Theorem 6.13, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And 6.14 says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So let's explain those really quick. So here's a quick help. A rhombus is the diagonals bisect each other. So imagine if we had a rhombus, for example. Okay, it's saying that the diagonals, let's go back to that. It says the diagonals of this rhombus bisect the angles. So what that means here is that this angle and this angle are congruent, and this angle and this angle are congruent, and this angle and this angle are congruent, and so are these two. So that was Theorem 6.9. Theorem 6.10 states that the diagonals of a rhombus are perpendicular. That means that when we have line segment BD and line segment BC, it means that this angle is 90-degree angle, so are the other ones that are located here too. So all 4 of these create perpendicular or 90-degree angles. Theorem 6.12 states that in a rhombus, one diagonal bisects 2 angles of a parallelogram. So this essentially is just like this theorem up here. It also says for a rhombus, the diagonals are perpendicular to one another, which we showed in 6.10, so they're kind of just referencing back the earlier ones. The last one is different though. It says in a rectangle, the diagonals are congruent. So let's pull up a quick image really quick. So we have this rectangle, and in this rectangle, this line segment and this line segment are congruent, but this is the case in a rectangle. So now we're going to try a couple of practice problems. It says for each parallelogram, determine the appropriate name, square, rhombus, etc. Find the remaining angle measures. Because we have a quadrilateral and because this angle on the bottom right corner is 90 degrees, then that means that this has to be at least a rectangle. Now because it's a rectangle, okay, again, we know it's a rectangle because of that 90-degree corner. Because it's a rectangle, then we know the angles bisect each other. We also know we have alternate interior angles. Therefore, angle 3 is because it's an alternate interior angle to the given. Okay. Because angle 3 is 70 degrees, that means this angle right here, is 72 degrees. Now if that angle right there is 72 degrees, and because we have one big triangle right here, and in each triangle it's 90 or 180 degrees. That must mean that this angle right here is also 90 degrees. But we want just angle 1. So now, because this angle is 72 degrees, we know that this corner is 90, we still have to figure out the rest. We know that this corner right here is also 72 degrees because of alternate interior angles. Now, if you look at it, this triangle in blue, and because this angle is 72 degrees, then angle 1 must also be 72 degrees. Okay. Now because that's the case, and we know that this bottom right side is 72 degrees, angle 1 is 72 degrees, that gives us a grand total of 144 degrees. And if we look at this little triangle in blue, and we know we have 144 degrees total, then we have to come up with the 180, which would mean that angle 2 equals 36 degrees. And because we have supplementary angles with 2 and 4, that must mean that angle 4 equals 144, and it'll have a rectangle. Let's try another problem. So given the parallelogram, determine the appropriate name and find the remaining measures. So in here, because all 4 sides are the same, we know that we have a rhombus. And because in a rhombus, all of the angles the diagonals bisect each other, we know that angle 1, because of alternate interior angles, is also 59 degrees. We know that angle 2 and 3, because the diagonals of a rhombus are 90 degrees. Then angle 4 because a diagonal bisects the angles, so that's all 59 degrees. So because none of them are right angles, we just know it's a parallelogram and a rhombus, and that's all. Now, it's your turn. Try these 3 problems, write them on your notes, and that's all. I'll see you guys next time.